Hello everyone, my name is Manohar Vohra and today I'm going to be talking about power factor. So let's look at the origin of this term in electricity. We know that in AC circuits, voltage and current fluctuate to form sinusoidal waves. To calculate power in such a circuit, if we take the instant values and use the previous formula we've used in DC circuits, we would end up with the instantaneous power. To calculate the overall power, we need an average of voltage and current known as the root mean square values. Along with that, due to there being a phase difference between voltage and current, we will need the power factor. So let's look at an analogy about a lemon spoon race. We have the finish line, we have the most efficient path, and a possible path. So you can see over here, we've wasted this energy right over here. We don't see this. Let's convert this into an electrical system now. The most efficient path being the resistive load in the circuit, true power. And this part we're going to be calling the reactive power. This is due to the reactance of a circuit. Reactance is due to components creating an electric field or a magnetic field in the circuit, inductors and capacitors. So X is the reactance, and we're going to be calling the total part, the hypotenuse, we're going to be calling that the apparent power. This is the total sum of both of them. And Z is known as the impedance of the circuit. So for just your information, I'm not going to be focusing a lot about this, but you could use these two diagrams to calculate reactive power and apparent power. Another thing to keep in mind is that voltage lags in capacitors and in inductors it leads. And the angle is this angle right over here, theta. And this is the real reason why we have power factor. So let's head on to what is power factor. It is the ratio between the real power or the true power and the apparent power. So in the previous diagram, that would be the cosine of the angle. So we end up with this formula, the root mean square values, just to remind you, and the phase difference, like I mentioned, cosine theta will be the phase difference. So let's look at this diagram of a resistive load and an inductive load. You can see in the resistive load we have unity. The cosine of 0, due to them being in 0 phase difference, cosine of 0 would end up being 1, giving us the most efficient we can get. In an inductive load, we are lagging behind by 90 degrees. In this example, not usually, it doesn't have to be 90 degrees. So due to this being 90 degrees, it would be the most inefficient, since cosine of 90 would be 0. So in this video, you learned that power factor is the ratio of real power or true power and apparent power, and we need it to calculate power in an AC circuit. Thank you.